Hi guys, this is for the people who were absent, or maybe they just needed a little extra help with the math. Maybe they zoned out in class a little bit or something like that. It happens. This is a review on what to do as we go from velocity to acceleration. How do we do those math formulas? So you guys should already have this sheet right here. This sheet right here, we've already done the velocity equations. We've taken down what the basic equation for speed and velocity is, and we've broken it down to how we can solve it. If I give you two of the three variables, you can solve for the third variable just by using one of these three equations. So what I want to do is I want to do the same thing with velocity, the change in velocity, and acceleration. First thing you need to know is when you see this symbol right here in a math equation, okay, that doesn't mean triangle. What that means is change. All right, so let's take a look at this first formula right here. Here we've got that symbol, and basically that's what that symbol is. That triangle is actually called delta. So this would be delta V. So delta V means change in velocity. And what's that change? Well, you have the initial velocity, how fast it was going when you started measuring, and the final velocity, how fast it was going when you stopped measuring, the last velocity. So this is change in velocity equals velocity final minus velocity initial. So right here, we just go right here, change in velocity. Okay, this is the final velocity, and VI is the initial velocity. All right, now if I give you the final velocity of the initial velocity, well, you know to use this formula. So we're going to highlight that, saying this formula is important. There we go. And this is going to be our cheat sheet. You guys can use this on the test. But what if I give you the initial velocity and the change in velocity? How can I do the velocity final? All right, well, let's go back to our notes here. If I have change in velocity, delta V, equals velocity final minus velocity initial, all right, I want to keep velocity final there, but I need to get rid of velocity initial. So how do I do that so I isolate this variable? Well, to do that, since this is a negative velocity, I want to add velocity initial to it. So negative velocity a minus velocity plus a positive velocity will come out to be 0, and that will leave velocity final alone. But if we do that on that side, we got to do this on this side. All right. So basically what that means at this point is we're just going to bring this velocity final, and what we have is change in velocity plus velocity, and that's how we solve for velocity final. So velocity final equals change in velocity plus velocity initial. All right, so that's easy. We can solve that pretty quickly. What if I give you the velocity final and the change of velocity? How will we solve for velocity initial? Well, okay, let's look at that same format again. All right, so change in velocity is equal to velocity final minus velocity initial. All right, now this gets a little bit confusing because now, okay, so I want to keep the velocity initial on this side and get rid of the velocity final on this side. So same thing again. Since this is a positive velocity, I'm going to say minus velocity final. That's going to equal 0. And then do the same thing on this side, minus velocity final, and that's going to equal 0. Okay, that means change in velocity minus velocity final is going to equal velocity initial, except that this was a negative number, so this is a negative. Oh, can't have that. So we need to figure out, how do we get rid of this negative velocity initial? How do we make it positive? Well, basically, very simply, I'm going to multiply it by -1 on either side. Okay, this is basically saying the same thing as -1 times velocity initial. So -1 times -1. When you multiply two negatives together, you get a positive. So two negatives equal a positive. That would equal, so -v times -1 will come out to be a positive 1v, or just v, initial. All right. Over here it gets a little bit more complicated, because now we're taking this -1 and we're going to have to multiply it by this. This -1 turns this velocity into a minus, change in velocity, and turns this one, well, since this is a minus already, we got to turn it into a positive. So really what happens is the negative velocity f final turns into positive, and the change in velocity is not going to be a negative, so that final formula is going to be velocity final minus change in velocity will equal velocity initial. All right. So if we're looking for the initial velocity, then we want to use this formula. All right. So that makes things nice and simple. Let's highlight those. We're going to highlight those, and those would be those three. If I wanted to know the change in velocity, those would be maybe the three ways I would throw those at you in a math question. But this is all about acceleration. And acceleration is the rate, or the amount of time. When I say rate, I'm talking about the amount of time it takes for the velocity to change. Okay? Like a Volkswagen Bug is going to go from 0 to 60, but the rate in which to go, the amount of time it's going to go from 0 to 60, is going to be rather slow by car speeds. But if you've got like a Shelby Mustang, well, that's going to go from 0 to 60 in a fairly short amount of time. So the rate of change of velocity is going to be fast. It's got a faster acceleration. So acceleration is how fast, the amount of time it takes to change the speed, whether we're increasing the speed or decreasing the speed. It also is changing the direction too. Acceleration is a vector, so it's speed and direction. We're just going to be working on the change in speed today. So acceleration, A is going to stand for acceleration. Okay. Change in velocity, change in v, that's your change in velocity. This is the same thing that we just saw for here, all right? So this just means change in velocity. And of course, t, well, that don't make sense. It stands for time. All right. So what I'm probably going to give you guys is either I'll straight up give you the change in velocity, but more realistically, I'm going to give you the final velocity and the initial velocity, and that's really what this is. So this is really saying the same thing as acceleration is equal to change in velocity, which is velocity final minus velocity initial. All right, that's change in velocity divided by time. Okay, I kind of wish I would have had that somewhere in here to put there. Maybe we can write it right here in the margin. We'll just write this so we know that acceleration equals velocity final minus velocity initial divided by time. That'd be a good place to put that, to remember that's really saying the same thing as what I'm saying right here. All right, so that would be a formula that we would want to save. And of course I throw my marker away somewhere and I have no idea where I put it. So I can, found it. I told you, I'm not fixing any errors in this video. So, there we go. No little, I'm not an influencer, I'm a teacher. You get what you get, and you won't throw a fit. Okay, so what if I gave you the acceleration and I gave you the time and asked, hey, what's the change in velocity? How would I solve for that? Well, this is very similar to what we did to get these questions. Okay, so if acceleration equals change in velocity, that's a v, not a u, divided by time, all right, then what I want to do is I want to find the change in velocity. So I want to keep that, I want to isolate that variable, which means I need to somehow or another disattach that time. And in order to do that, we inverse and multiply. So we're going to take, so this is in the denominator, we want to multiply it by t being in the numerator over 1. That's really cool, because if I'm multiplying and I have something in the denominator, it's the same as the numerator, they cross each other, they cancel each other out. It's just like saying t over t. Well, t over t, what if t was 4 seconds? So 4 seconds is time. That means this is going to have to be 4 seconds. 4 seconds divided by 4 seconds is 1 second. And anything multiplied by 1, it's change in v, it's going to be 1. Okay, but if I do that on this side, I have to do it over on this side as well. T over 1. Okay. Now, change in velocity. We got rid of the t, and it'd be velocity over 1, which would be, well, change in velocity. All right. T over 1 is just t, so we're just going to multiply acceleration times time. All right. Well, that's exactly what we were looking for. Change in velocity, that's what we're solving for, equals a times t. Acceleration times time. And we could also write this again. I'm a little bit of room down here this time, so we can write this out. Change in velocity, remember, this is your change in velocity right here. So this is saying the same thing as velocity final minus velocity initial equals acceleration times time. Right? Well, what if I want to solve for time? Okay, well, let's take this same formula. Change in velocity equals acceleration times time. I want to keep the time. I want to isolate it. And I want to move that acceleration so time can be by itself. Time just wants to be alone. Some alone time. Okay. So how do we do that? Well, same thing. We inverse and multiply. This time, instead of taking, we want to get rid of the acceleration. So we're going to multiply this by, well, this is in the numerator, so this time I want to put it in the denominator. So that way they cancel each other out. So that would be t times 1. The accelerations cancel out. So that's going to leave it as just t by itself. But of course, if we did it on that side, we got to do it on this side. 1 over acceleration. That leaves the change in velocity. 1 times the change in velocity is going to be change in velocity. Divide that by acceleration. So change in velocity divided by acceleration equals time. Okay, so we can write that here. Time equals change in acceleration. Sorry, said that wrong. Change in velocity divided by acceleration. Once again, just like this question, change in velocity can be written this. We can also write this problem as velocity final minus velocity initial divided by acceleration. All right, but these are your key programs. I do this so I don't smudge ink everywhere when I highlight. Okay, which means now I have ink on the back of my hand, but that's cool. things I do for you. All right, so that's where we're going to end at with this. And as you can tell, we have something that says F and something that says M. We're going to worry about that, well, in January, February, somewhere in that time. Okay, so there we go. We've got formulas for speed, we've got formulas for velocity, we've got formulas for change for velocity, and we've got formulas for acceleration to work from. So if we go back and look at today's assignment, which is 2.0.8 acceleration math practice. Now in class I did the skater question, and I think what I'm going to do is instead of doing that one again, I'm going to do question number 1. But since this is an assignment that you guys are supposed to be working on, you're going to have to figure out the answer yourself. Okay, so the question actually says, while traveling along a highway, a driver slows from 24 meters per second to 15 meters per second in 12 seconds. Now I realize I'm off screen here, but I'm going to write this down. Okay, so the driver slows from 24, and I'm writing this down on a piece of paper. I'll show you the piece of paper in a moment. Meters per second. So that's from 24 meters per second to 15 meters per second. All right. Now I recognize that as being velocities. 24 is, when it says from, that means that's the start. We're going to go from here to there. So from is the starting one. So that would be initial. And that's a velocity. All right. I know it's a velocity because it says meters per second. So this is going to be your velocity initial. All right. And he's going to slow to 15 meters per second. Well, 2, that means that's where we're going to. So that's going to be the final destination, right? So that's going to be our velocity final. Once again, I'm writing this. I'll show you this here when I'm writing on the paper in just a moment. And then we're going to do this in 12 seconds. All right? So that's the amount of time. The question goes on to say, what is the automobile's acceleration? And there's a little thing right there that says, remember that a negative value indicates slowing down or deceleration. Technically, there's no such word as deceleration. It's a word we kind of made up. There's really only acceleration, positive acceleration, which means your speed is increasing. So if like you're getting into your car and you're going from 0 to 60, that would be positive acceleration. But if you're going 60 miles per hour and you hit some traffic and all of a sudden you're slamming on your brakes, come to a stop, well, you're not going to go from 60 to 0 instantaneously. That would throw you out the window. Hopefully you don't do that. You're going to slow down from 60 to 0 very quickly. So the rate in which you slow down from 60 to 0 is going to be a negative acceleration. Yeah, we commonly call that deceleration, but the actual terminology we want to use is negative acceleration. So if you get a negative number, that means it's slowing down. And that's what it's saying is going on in this question, is that the driver is slowing from 24 meters per second to 15 meters per second. And now that we've seen the question, and I've highlighted everything that's important with that question, I'm going to go back to my camera. So we saw that he started at 24 meters per second. All right, you can see I messed up when I was off screen. That's why I had to draw over that too. 24 meters per second. That was my velocity initial. He slowed down to 15 meters per second. That's my velocity final. And he did this over 12 seconds, which is time. All right, and it says what is his acceleration as he slows down. So what are we looking for? We're looking for the acceleration, or A. All right, so A is what we want to know. All right, this is what we know. Now, I've given you everything that you need at this point to solve this question. From this point on, you have two things you need to do that are made super simple. 1, you have to determine which formula to choose. 2, you have to take that formula and put these numbers into that formula. I call that plug and chug. All right, you plug those numbers into the formula and you chug out the answers. So which formula are we looking for? Well, it says right here, I'm looking for acceleration. So I'm looking for something that would be like A equals. Well, A equals is written right here. A equals velocity, change in velocity times time. Now, I didn't give you change in velocity, but I did give you velocity initial and a velocity final. So that really would be using this formula right here. A equals change in velocity, which is velocity final minus velocity initial divided by time. All right, so A equals velocity final minus velocity initial divided by time. All right, so velocity final, well, that was 15. So now we've got the formula. Now it's plug and chug time. We just got to put things in the right place though. So 15, all right, 15 is going to be 15 meters per second. All right, and I'm going to subtract the velocity initial, which is this one right here, which is 24 meters per second. And I'm going to divide that by time, which was 12 seconds. All right, so now we got to do 15 minus 24. What is 15 minus 24? Yes, I could do this in my head, but for the sake of time, we're just going to show you how to do this on the computer, the calculator. Did you guys know a calculator is a computer? It was the only computer I had when I was growing up. That comes to -9 meters per second. And we haven't got rid of the 12 yet, so -9 meters per second divided by 12 seconds. All right, well, now we got to take -9 and we're going to divide that by 12. And that's going to be, oh my gosh, it comes out with a negative number. How wrong is that? It's not wrong at all, because like I told you, acceleration is the same thing as, acceleration, if you're speeding up, it's going to be a positive number. But this question says the car is slowing down. So it's decelerating, okay, the wrong word to use, or it's a negative acceleration. So slowing down, it should be negative. So that comes to -0.75. Now here's where it gets weird. Meters per second, but I didn't get rid of the seconds. So it's meters per second. Okay. Remember that velocity is a measure of how far something goes divided by time. And that's a rate. Distance divided by time. Acceleration is how the velocity changes over time. So we're looking at the velocity, meters per second, and we're figuring out how much it's changing over time. It's like we're measuring time twice. And if that seems weird, just understand that that's exactly what we're doing. We're looking at the time that makes the velocity, but we're also looking at the change in time. So how we resolve that here is you see seconds. Here it's a little mini fraction right here, right? Meters in the numerator, seconds in the denominator, and then the overall fraction, we have another denominator that has seconds. When that happens, the denominator that's up here in the mini fraction gets dropped down into the regular denominator. So now that becomes -0.75 meters per second times whoa, no, that doesn't make any sense. Why would somebody write seconds times seconds? That's almost like a little bit confusion. All right, seconds, not fives, those are seconds. Well, there is a simpler way of putting this. That would come to -7.75 meters, and a way of saying seconds times seconds. simply can be put meters per second squared. And that's it. That's all there is to it. So hopefully what we've done here is I've given you guys a simple kind of cheat sheet to help you guys go through and find the easiest way to solve this, and shown you guys how to plug and chug those answers in. And all the questions should be like that. And please, for God's sakes, don't go to ChatGPT. Don't go to, Google Gemini. Don't ask the S lady or the A lady. I can't say their names, or I might activate my phone for the answers. And what I'm finding out is with artificial intelligence, it's almost like it sounds. It's artificial. There's no intelligence to it. I am getting so many students getting so many wrong answers just because they're using ChatGPT GPT to do that. So do your best to learn this. And it's like I told my kids in class, most of you guys are juniors at this point. This is the last time you get this for free. So I hope you guys take this, learn this, know how to do this. It's not hard. It's super simplified. You should be able to do it. I believe that you guys can do it. So that said, with me saying I believe you, love you guys, I am going to end this video until you have a wonderful day. Bye now.